Okay, so we're going to try this one more time. We're going to go ahead and go to example number 5. In example number 5, you're actually going to do a LINREG this time. Okay, so if you look at the example, it says table 1.4 shows the average life expectancy for a person born in the United States in each given year. And it gives you the data. Thank God the life expectancy has been going up every decade. Okay, so again, go ahead and go to L1, L2 and plot those things in there and see if you can reproduce the scatter plot of figure 1.2. So again, the reason why we're doing this again is because this is very important. This will come up over and over and over again. You will do this after you graduate, where you go to college, whether you're taking a lab, whether you're doing research, whether you are, you know, you are in the economics division, you're taking a degree in economics or any kind of thing that does research. You're gonna have to do this. Okay. And yeah, go ahead.
Is it LINREG we're doing?
Yeah, we're doing LINREG here. We're going to do a linear regression this time. Whether it's AX plus B or A plus BX doesn't really matter. I prefer AX plus B because it's just easier to read. And you should.
What are our dimensions?
0.175 and 68.2. Did everybody get that? If you got that, raise your hand.
Wait, I meant like the window.
Oh, the window. Okay, so let's look at the window. So on the X, you're going from 0 to 60, correct?
Yes.
So your X window should be set accordingly, right? You should set your, I would set my X min to 0, my X max to, I don't know, 75, I guess, or 80, just give you some room. Whereas the Y goes from 68.2 to 78.7. So I would go from 0 to 80 or 0 to 85 or something like that in the Y window. All right, if you got it, go ahead and raise your hand. Okay. All right, okay. All right, Allison got it. All right, Sarah got it. Okay, good. Sam's got it. Okay, all right. Okay, so what did you get for A and what NB there? Sam, what was your A value?
Sorry?
What was your A value? When you do the regression, what do you get?
My brain is not
Trembling.
All right, all right. Ezekiel, what do you get for your A value?
How do you calculate that? Is it LINREG?
Yeah, do a stat calc LINREG.
I got a decimal. Is that correct?
That's correct.
0.17?
0.17, that's good. What do you have for B?
67.9.
That's great. Good work. Everybody else got that? Or something close to it? Yeah, good. Okay. So basically what you found is that the A is the slope of the line and 67.9 is the y-intercept, right? Because it's AX plus B, okay? So what you found here is called the line of best fit, okay? Specifically what you found and what the calculator found for you is called the least square regression line, okay? If you ever have the opportunity to take a stats class with me, we will go a little bit more detail of the least square regression line. But you have just found the least square regression line, which is, so a line of best fit that you draw or I draw could be different, okay? Depending on how we interpret it, okay? Another method is to use the two endpoints. So the lowest X value and the highest X value, and just draw a line through that, okay? That necessarily does not work sometimes, okay? So the least square regression line is a more commonly accepted best line of fit, okay? And that's what you calculated there. What was the R squared value? Anybody have an R squared value for me? Did we get somewhere around 0.95 or we get higher than that? Anybody? Brooklyn, what did you get for your R squared value?
I got 0.9909.
9909. So that is a very high regression correlation value. So that means that this line that we found is very, very good in predicting what we want to use when we're doing a prediction. Okay, good. So let's go and flip the page. So if you are still kind of iffy on this, okay, by the time the test rolls around, you need to be not iffy. You need to know this inside and out, how to do this. Again, like I said, this is going to be on the test. And I am not going to take the excuse that, oh, I never figured it out, Mr. On. If you go to YouTube, there are gazillion videos on how to do this. Okay, so do it. Find one that works for you and make sure you're able to recreate this. Okay. All right, let's go to page 68. Now we're going to talk about zero factor property. Okay, the zero factor property is nothing more than if A times B is equal to 0, that means that this has to be 0, or so A has to be 0 or B has to be 0. Okay, and that's all that means. So if I do a factor, one of them has to be 0. So let's do example number 6. In example number 6, I have 6x cubed is equal to 11x squared plus 10x. Okay, so I'm going to move everything over on this side. I get 6x cubed. We're solving this algebraically now. X squared minus 10x. So if I pull the x out, 6x squared, 11x minus 10. So I have a quadratic form here, right? Which means that now I can factor. The first thing I can do is try to factor it, okay? So if I try to factor this, no, that doesn't work. No.
15 and 4, Mr. Ron. Negative 15 and 4.
What?
Nervous.
Where's there a 4? Where am I getting a 4?
From factoring.
Yeah, there's no 4 here because this is going to be 1, 6 or 3, 2. This is going to be 2, 5 or 1, 10, right? Oh, here we go. No, that's not it. 6, 10, no. 2, 3, 4. Oh, there you go. Okay, I see what you meant by 15 and 4. Okay, you're good. Good job. So 2, so this would be plus, and this guy would be negative. There you go. That works. So we're going to get, so this is going to be x, 2x minus 5, 3x plus 2. Okay. So for those of you, if you were not able to factor this, what do? Am I done? I can't do it or what? What happens if I can't?
You're done.
Huh? You throw it in the quadratic equation, right?
No, you just leave it alone.
Just leave it alone. So x is equal to negative b plus or minus square root of b squared minus 4 times 6 times negative 10 over 2 times 6. If I throw it in, so I'm putting in the quadratic equation here, right? So let's move over. Well, I'm going to get 11 plus or minus square root of 121. I have a minus and a minus, they become plus. I have 240 over 12, 11 plus or minus square root of, what do I get? 121. So it'll be 361 over 12. 361 is the square root of what? Does anybody know? 19, isn't it?
19.
19, right? So 11 plus or minus 19 over 12. So when it's plus, I get 20 over 12. When it's negative, I get negative 8 over 12. So that's what I'm going to get here, right? Because I'm going to get either this is 0 or this is 0 or this is 0, right? So I get x is equal to maybe 0 or 5 over 2 or negative 2 over 3. Does everybody know how I got this negative 2 over 3 and negative 5 over 2? Do I need to go over this? Basically, I'm setting this to 0, right? 2x minus 5 is equal to 0. Over here, I'm setting the 3x plus 2 is equal to 0, right? If I solve for this, I get this guy. If I solve for this, I get this guy. So this guy here is the same as that guy. This guy here is the same as that guy, or no? Oh, this is 30, not 20. 11 plus 19 is 30. So divide by 6, I get 5 over 2. Divide by 4, I get negative 2 over 3. Okay, so it's the same thing. So even if you were not able to do the factoring, if you just throw it in the quadratic equation, you should get the same result. Okay? So your answer is x equal to 0, or 5 over 2, or negative 2 over 3. Okay? That's how you do that. So if you go to top of page 69, there's a blue box there. Go ahead and read that for me about the zero factor property. Go to example number 7, solve the equation, comparing models. So I have x squared is equal to 10 minus 4x. X is squared plus 4x minus 10 is equal to 0. Again, we're in the quadratic thing. I have 1, 10, or 2, 5. There's no way I factor to get 4, so I have to throw it into the equation, quadratic equation. Negative 4 plus or minus square root of 4, negative 4 squared plus, oops, not plus, minus 4 times a times c over 2a, negative 4 plus or minus square root of 16, negative becomes plus 40 over 2, negative 4 plus or minus square root of 56 over 2, negative 4 plus or minus square root of 56. Square root of 56 is the same as square root of 4, square root of 14. This becomes 2 root 14. So this is 2 root 14 over 2. The 2's, this one cancels out. I get -2 here. -2 plus or minus square root of 14. In other words, so in this class, if you leave it here, you do not get full credit. You have to go the next step and go ahead and do the simplification here and then simplify it down to here. So if I asked you on this question to solve for x, okay, and instead of giving me this, you go to your graph calculator and come up with the answer 1.74165 and -5.74165. Okay, I am not going to dock you for writing this, right? Because I asked you to solve it. I did not tell you what method to use. Okay, between these two answers, so I have one answer that looks like this, and I have one answer that looks like this. Which one is the exact value? Can anybody tell me which one is the exact value?
The one with this root.
The one with the square root. This guy here is the exact value, right? Because there are actually more decimals down here that go infinitely long, right? So this is more of an estimate or approximation, not the exact value. This guy here is the exact value. So if I put on the test, I give you this equation, I say, solve, give me the exact value, and you give me this, you're not going to get full credit because this is not the exact value. This guy here is the exact value. Also, if I ask you to solve this algebraically, then I'm looking for this. If you give me this, you do not get full credit. Okay, does everybody understand the distinction there between the exact value, solving algebraically, solving graphically? There's distinct differences here. Okay, let's move on. Let's go to page 70. And if you look at the top, there is a blue box there. Read that for me. Okay, so the root, solution, 0, x-intercept are all the same thing, right? It's all means the same thing. Okay. So let's go to problem solving. There in the middle, there's a purple box. There's Polya's 4 problem solving steps. So if you know how to do this, you don't know how to do, you're all done with your honors pre-calc. You don't have to do pre-calc, you have to do it, don't have to do anything more. So you have to understand the problem, devise a plan, carry out the plan, look back. Okay. So it's really, I mean, it's not really telling you much here, right? Okay. You have to be able to do all these things. Okay. Let's see. Example number 8. Let's do example number 8. Example number 8. Engineers in an auto manufacturer pay students 8 cents per gallon, X cents per mile, plus $25 a day to road test their vehicles. So the total amount that I'm going to be paid is 8 cents per mile. So this is the number of miles. And then you add the $25 per day, right? So A, how much did the auto manufacturer pay Sally to drive 440 miles in one day? Well, I would just put 440 into here, right? So it'd be 0.08 times 440 plus 25, okay? If you do that, you're gonna get $60.20. Then B, John earned $93 in one day. How far did he drive? So in that one, you're gonna go, they're actually giving you the Y value as 93. So this is 93, and you have to solve for X. So you'd move the 25 over, 0.08X. If I do this, I get 68. 0.08x, so you divide both sides by 0.08, and if you do that, you get these go away. X is going to be equal to 850 miles. Okay, so that's that. That's example number 8. And then they talk about grapher failure and hidden behavior. Okay, I'm going to go ahead and let you read that. I'm not going to do example 9 and example 10. I will leave you with one of my most favorite sayings about the graphic failure or calculator failure is that the calculator is only as good as the user, okay? In other words, the calculator is not going to do you much good if you do not know the principles behind what you're doing, okay? All right, so we're done.